Hi again, everyone. We're in our statistics class notes now on page 31, and we are talking about numerical measures for some symmetric distributions in section 3.1. We just got done describing what the standard deviation will do for us. I haven't talked about how to calculate it yet, but I just want to give an example of what it can give to us. Okay, so example 33, this is actually directly from your textbook. It shows the distribution of the amount of particulate matter, or smog, in the air in 333 cities in the United States in 2008, as reported by the Environmental Protection Agency. The mean, the average particulate matter, is 10.7 micrograms per cubic meter. Don't worry too much about the units, just think of the mean. Remember, its symbol is X bar, that's 10.7. And the standard deviation, which I haven't talked about how to compute yet, but the standard deviation is 2.6 micrograms per cubic meter. So 2.6 micrograms per cubic meter. So let's find the level of particulate matter that is both one standard deviation above the mean and one standard deviation below the mean. So if I'm going to go one standard deviation above the mean, what I'm doing is I'm taking the mean and adding S. So the symbol for standard deviation is S. That's an S. Some people think it looks like a 5 when they first see it. That's an S for standard deviation. So above the mean, one standard deviation would be X bar plus S. So that's 10.7 plus 2.6, or 13.3. So that's right around in here. Each one of these is, let's see, that's 9, 10, 11, 12. Each one of these are 2 wide, okay? So that's 10 to 12 here. The mean is in this, 10.7. And if I go one standard deviation above, I'm up here to about 13.3, somewhere in here, okay? And if I go one standard deviation below, it's 10.7 minus 2.6, which is 8.1, so here. So that means that between 8.1 and 13.3, the majority of the data will be in there. Majority, again, means more than 50%. So keeping in mind that the EPA says that levels over 15 micrograms per cubic meter are unsafe. So where's 15 on here? This is 13, 14, 15 is in the middle here. So anything over 15, these cities is where there is unsafe air. What can we conclude about the air quality of most of the cities in this sample? So most of the cities are between 8.1 and 13.3, according to our calculations here. One standard deviation above, one standard deviation below. Therefore, most of the cities have safe air quality because unsafe is over 15. All right, how would you compute this standard deviation? Actually, this is a mess. I really don't want you to ever do this by hand. But the way you do the standard deviation, so this is S. First of all, the symbol is sum. So you add up the difference between each data value and the mean. You take X minus X bar and you square each of those. So we have to square it because X minus X bar for values below X bar would be, below the mean would be negative and above the mean would be positive. These would just cancel out if I added them all up. So I have to square them so they're all positive differences. And then you sum them up and then you divide not by n but by n minus 1. And there's a mathematical reason you're dividing by n minus 1. It has to do with degrees of freedom. I don't want to spend any time on that. You're not required for that at all. But you don't divide by n, believe it or not. You divide by n minus 1. And then you take the square root of that whole thing because what we've done is we've squared the distances, so we need to get it back down into the proper units. Okay? So that's a description of how to do the standard deviation by hand if you needed to.